All right, in this video, we're going to quickly go through the first test on transformation. So it's test A, just to make sure that you've got the right one. So prior to this test, you had 5 minutes reading time. So in that time, you should actually be reading through every single question. Look at the ones that you feel confident with. And remember, tests, you don't have to start at question 1 and then go in order. You can start at whatever question you like. And it's always a good idea to skip anything that you don't understand and come back to it. And also, a lot of questions can be supported with the calculator. So make sure that you are, or you do know how to use the calculator and you are using the calculator. Okay, so first question, the basic parabola y equals x squared is translated 2 units down the y-axis and 5 units to the right along the x-axis. Okay, so our basic parabola in turning point form is y equals ax minus h squared plus k. So the k tells us whether it goes up or down, and h tells us whether it's left or right. So here it said 2 units down the y-axis, so that means k is -2, and 5 units to the right along the along the x-axis. So your h is 5. And then you can just fill everything in. Now the a in this case is just 1, so we don't have to worry about that. But the a is just a dilation factor. It doesn't really make any difference to how the graph moves. So remember, your a, let's say we have a normal parabola, can make it narrower or it can make it wider. But this spot here is still the same for all 3 parabolas. Okay, so the only one that could be is D. Moving along. Question 2, which of these parabolas is symmetrical about the line x equals 12? So with your turning point form, let's write that again. So your axis of symmetry is at x equals h. So in this case, we know x equals 12. So it's at h equals 12. So anywhere where you had 12 in your equation. Now, it doesn't matter what k is and it doesn't matter what a is, as long as h is 12. And when you think about that, let's call that point 12. So this is the line x equals 12, and your parabola is just split in half along that line. So those 2 parabolas, this parabola, they all have the same axis of symmetry. So symmetrical means it's the same on both sides, so you can kind of see the symmetry of the parabolas. So the only one that could be is B. All right, let's move down. Question 3. Which one of these parabolas has no x-intercept? So hopefully by now you can answer questions like this just by looking at your equations. You could also graph these on your calculators, but I'm not going to graph them because I think most of the questions on this test can be done easily without the calculator. Okay, so first of all, you need to understand whether it's positive. So this first one is a positive, the next one is positive, this one is negative, and this one is negative. Okay, now if we have no x-intercepts, when you have a positive graph, that means k has to be greater than 0. Okay, so basically your parabola is now moved up and it's not crossing the x-axis. So the only one that is greater than 0 is B. So this one has moved down 7, this one has moved up 7. Now if we just look at C and D, so C is they're pretty much the same graph. They've just, one's gone to the left and one's gone to the right, but they're both shifted up 7, so they're still crossing the axis twice. So the only one that could be is B. All right, moving along to question 4. In the equation y equals a times x minus h squared plus k, changing the value of the value of k will move it up or down. Okay, so that's, if you got that one wrong, I would be questioning what you've actually been doing for the first 2 weeks, because that was probably one of the easier questions. All right, the parabola with the equation y equals -x plus 5 squared minus 3 has. Okay, so It's a negative parabola, so first of all, it looks like that. So when your turning point is up there, it's a maximum. So I can eliminate A and I can eliminate C. Now my turning point is at HK. In this equation, remember, if you see a plus, just replace it with two negatives. So that means H equals -5 and K is -3. So your turning point is -5, -3. So your answer there is D. All right, question B. For each of these, state the y-intercept, the x-intercepts, and the turning point. Okay, so we can see straight away what the turning point is because it's in turning point form. So your turning point is -2, -4. So just make sure you plot that correctly. There it is there. So we get our y-intercept by letting x equal 0. So if I put 0 in here, I have 2 squared, which is 4. 4 minus 4 is 0, so I have a y-intercept at 0, 0. Now, if your y-intercept is at 0, 0, that means one of your x-intercepts is also at 0, 0, because that point there, and it's the only point on the graph where you intersect both the x and the y axes. So as soon as I got this one, I knew I had to get this one as well. Now, I'm going to show you another way, or the way how I got to the other x-intercept on this one. So remember, this point here, your turning point, is halfway. It splits your parabola in half. So if I've got this point here, and this point is 2 away from my turning point, then the other x-intercept must be 2 here. Okay, so that's one way you could do it, and that's actually how I did this one here, because your turning point is actually halfway between your x-intercepts. Okay, clear that. Come on, go away. There we go. So now I have my 3 points. Now it's probably a good idea to have 3 points, or at least your turning point and a point either side. Hopefully they're your x-intercepts. You should also have your y-intercept. So all these things here help us draw the parabola. The only problem is if we don't have an x-intercept, then we need to get some other points. All right, so I was just thinking, if you can put eyeliner on your eye, you should be able to draw a parabola. I don't know why I just thought that, but you kind of, when you're drawing eyeliner on your eye, you kind of start halfway. So here is just drawing the dots. So think about what works for you. And I'm sorry for assuming you all wear eyeliner, but I just thought that was a pretty cool example. So you don't have to always start from the top and go down like that. That's when you draw messy ones. Just start from going from point to point and, up and up like I did in that one there. You'll get a nicer looking parabola. Okay, let's move on. Okay, so this one here, we have a negative parabola. I saw that straight away because of the negative sign. The turning point is at 4, 6, so draw that point first. Your y-intercept, let x equal 0. So -4 squared, when you square a negative number, you get a positive answer. So here we have 16. Then -16 plus 6 will give you 10. So there's -10 there. Some of you had -10 in the wrong spot. So just be careful when you do that. And your x-intercepts, now this one here we didn't get a integer value, so remember an integer is a whole number. We got a third or an approximate value. So on your calculator you could have left it as a third, or you could have approximated it to be 1.55 and 6.44. So you actually had to have your point halfway between 1 and 2 and halfway between 6 and 7 here. And then, as I said before, join your dots and you're going to have a nicer. Now don't end your parabola there. If you have a y-intercept, you should go through that y-intercept. Okay, let's move on. All right, question 2. So we have a parabola that's been shifted along the x-axis 4 units and to the left along the x-axis by 3. So most people, excuse me, were able to get this equation, which was fantastic to see. Now with your when you sketched it, a lot of you didn't put in the arrow, so I actually took away marks if you did that, because I thought, oh, even though you drew it correctly and you did the x-intercepts and the phi fine, it did say indicating the two transformations using arrows and stating the transformation. So for this one here, if you have to draw the arrows, remember this point here is 0, 0. So if we've gone to the left by 3, we're going to here. So I've just done 1, 2, 3. So you can see we've gone along there, and then down 4. So your new turning point is here, and we can see that is negative 3, 4. Now, to have, I guess, other points, you can choose any point you like. So this point here is at 2, 4. And you could also say, all right, if I move that 1, 2, 3 across and then 4 down, 1, 2, 3, 4, there's my new point. So it can help you draw the graph. So let's say if you didn't know what this equation was and you had to draw your graph, you just pick points and do the same thing, because all those points have shifted. Okay, and that sort of stuff you go into more detail when you do methods, but if you're a little bit confused there, then it doesn't matter. Okay, and then when you stated the transformation, to the left 3 and down 4. Okay, this one here would have been hard, I think, if you didn't have the practice exam or practice test. So it was good to see most people, everyone I think attempted it, and most people got it right. So your general equation is here, okay, and always think back to linear. And if you get stuck, just say, well, in this sort of situation, what did I do in linear? And in linear, your equation is y equals mx plus c, and you would substitute in maybe the gradient and maybe a point in the line, and you're able to find c. This one here, you're given the turning point and another point that it passes through. So all you need to do is substitute in those values to solve for a. So your turning point is 4, 2, so that means h is 4, k is 2, just like I've done on the next line. So now we have a nicer looking equation with 3 unknowns, y, a, and x. Now x and y are just a point on the line. So here's a point that was given to you, 2, negative 4. You can't use the same one as before, even though it is on there, it just won't work for you. So you need to use 2, negative 4. So we substitute that in. Okay, and then we keep solving. So you could have used solve on your calculator at this point. Okay, if you wanted to, solve for a, or even if you did it by hand, it's not hard to do, but you can check your answer on your calculator. So when we get a equals negative 1, what we do is we substitute it back into our equation. So this is what we had before we found a. So a was negative 1, so you'll see I've just put a negative in there. So we get y equals negative times x minus 4 squared plus 2. And you can also put that into your calculator and just say, all right, does this graph have a turning point at 4, 2? And does it pass through the point 2, negative 2? And if it does, then you know you've done it right. Okay, well done, girls. You did really well on the test, and hopefully you continue to do really well. Good stuff.